Hi guys, welcome back to our Let's Pull It Together sessions. Now, we've put out 4 videos so far for the month of January, so I just wanted to have a check-in and let's review some of the things that we've done so far. So what we've done so far is we have set up the Juniper switch management, both the in-band and the out-of-band. The in-band being using the VLAN and the out-of-band being the dedicated management port at the back of the switch. We've also done some VLAN design and configuration, as well as assigning ports to VLANs. We've also, in our last session, we handled some inter-VLAN routing, which is enabling users who sit in different departments to see each other on the network itself. Today, what we're going to tackle is DHCP configurations, which is session 4. So this is basically going to show you all on a high level how DHCP works. I'm going to keep it a bit simple. I'm not going to get too technical. So this is how it works. So we have a user who's plugged into the switch. The first thing that happens is the client would send a DHCP discovery towards the DHCP server, which in our case is the Juniper switch. What the switch or the server would then do is send an offer message to the user, including the IP address that it could use, the network mask that it could use, your gateway, which is what enables you to communicate into VLANs, in between various VLANs, and some other parameters. What's going to happen next is that the client would send a message back to the server saying, hey, I am okay with this address and we're good to go. And then the switch or the server would then send back a message saying, okay, no problem, we're good to go. And the switch or the server would then remove that IP address from the pool. Now, the pool that I would set up would range from 10 to 254. How it works is that usually you can use from 0 to 255. 2 IP addresses are usually set aside. One is your broadcast, which is your 255, and one is your network ID, which is 0. So your range can typically be from 1 to 254. Now, in my configurations, you would see that I have my setup such that I would start my scope at 11. Reason for that being is that just in case somebody wants to have a printer in that particular subnet, I make sure and I leave some addresses out of the scope that would never go to users. So if you have anything that you need to put in that VLAN after, whether it's a server or a Wi-Fi device or printer, that allows the customer or the user to have that range available from 1 to 10. Well, from 2 to 10, because 1 would be my gateway IP. So once it's done and the client gets an IP from the server, what would happen is that the user would then have that IP for the set time or the lease time of the address. So what you can do is set up a maximum lease time, which would allow the client to only hold that IP address. So the 20.11, for example, the user would only hold that IP address for the specified amount of time. After that, the IP address would change. So what we are going to do now is actually get into the configuration of the DHCP. So let me I have my script up and our party session 92.168.2. You would also see, once this is done, that you will be able to access the switch via any of the gateway IPs. Again, this is the script of all the things that we were configured so far. So I'm just going to go down to the DHCP configuration. Oops. And we go into edit. So the first thing we need to do is delete system services DHCP. That's a default config that comes on the device. It's a legacy configuration that isn't compatible with the DHCP local server. So we have to take that off. So this is the first thing we are going to do. Actually, let me leave it for now so you all would see the error that it would throw. So let me just move this. Right. So the first thing we need to do is create a local server group that ties into the layer 3 interface for the VLAN. So if I scroll back up into our configurations, you would see when we created the layer 3 interfaces in our last session, we tied them to the VLAN using the VLAN dot and the VLAN ID. And that also ties into the IP addressing. So we had to create a group Now it's one group, it's a single DHCP group that would have the 4 VLANs. The reason being, VLAN 10 is for access. So let me just show VLANs. If you all remember, VLAN 10 is for the access. So that's just between your switch and your firewall. So you do not want DHCP on that VLAN, because that would mean that you're opening up your firewall to have other users sitting there, which we do not want. We also would not have DHCP for this VLAN, which is net management. Reason being, all of your management devices, all of your switches, all of your routers, all of your servers should be statically assigned, because like I was saying earlier, if these devices are assigned a DHCP IP, once the lease runs out, they may not get back the same IP. So if the IP changes, you would never know, and you would not be able to access the device anymore. So we are going to enter this group of commands. The second thing we need to do is create the range for each, the network and the range for each of the VLANs that we would have put in the group. So the first one being user is 20. So as you can see, it's VLAN.20 up here, and the subnet for that 192.168.20.0. So the first thing we need to do is set the network. The second thing we're going to do is create a low range. Like I said before, I usually keep 2 to 10 for any devices that may come up after, whether it's a server or a printer or a wireless access point. I usually leave some addresses. That's just my design. It doesn't have to be like that all the time, but I just prefer to always have that, because sometimes what happens in customers' environments is that all of a sudden they would know that this server is just for this group of users, and they would want to put the server in that VLAN to avoid the amount of inter-VLAN traffic they are creating on the switch. So usually what happens is that you end up having to shorten the scope after implementation. So I prefer to just shorten the scope before it's implemented. If we need more IPs, you can use a different subnet mask. So a /24, like I said in my previous videos, give you 254 usable IP addresses. So my range would start at 20.11 and end at 20.254. The name server, which is the DHCP attributes name server, you can't see the end of it, but this is a Google IP. So each group that needs internet access, the name server is for DNS, which is the resolution of the IP addresses to the domain names. So I use 8.8.8.8, which is Google's IP, one of Google's server IPs. And then I would have the DHCP attributes router, which is my default gateway IP. So I'll go ahead and paste this in. Now, it should be noted that you can have multiple name servers. So let me paste these two, because these two are identical to the first one. The last one, I included 2 name servers. I included 2 of Google's IP addresses. So as you can see, it's the 8.8.8.8 plus the 4.2.2.2. It's just for more resiliency, just in case one server goes down, you have the other one that would be accessible. You have some other attributes. For example, you have the maximum lease time that I mentioned earlier. That would be the maximum amount of time that that client would hold on to that IP for. Those features would work in a guest environment. For example, the guest Wi-Fi, we could actually set the maximum lease time on this. If I do a question mark, you could put the amount of seconds. So let's say we give them 6,000. So that's 6,000 seconds. Because we don't want somebody using up all of our IP addresses, especially if it's public Wi-Fi, and they are not on the network, or they are not using a network. So let me run a commit check. There we go. So this is the error I was talking about. So if we go, the edit system services DHCP, which is the system services DHCP, is not compatible with your system services DHCP local server group. So like I said, one is a legacy configuration, one is an adaptation of that legacy configuration that works better for me in my designs. So I will copy this. Now if I do another commit check, it should be fine. Point to also note is that even though I have VLAN.20 and VLAN.30, etc., even in the layer 3 interfaces that I would have had higher up, the newer devices, it changed from RVI or routed VLAN interface to IRB or integrated routing and bridging interfaces. So instead of VLAN.20, it would have been IRB.20 or IRB.30. It's just a difference in models. So this is a 2200. 2200 use the VLAN dot. The 2300s, which are the newer versions of the switch, those are IRB dot, like 3300s, the 3400s, the 4300s, all those higher model switches uses the IRB dot configuration. So let's do comment DHCP, and we should be able to test. What we will have to do is go back and look at the ports that we can plug into, and I will test them using pings. Let's give this a second. Now, note that I am using the management interface at the back of the switch to access the switch right now, which is the 192.168.200.1. If you all recall, that IP address does not exist anywhere on your network. It's just an IP assigned to the port at the back of the device. So what I'm going to do now is let's just show the configuration. So as you can see, we have our DHCP local server group. So I'm going to plug into port 2, which is user. Now for user, I believe our configuration for that 192.168.20. So if I take off my device from the switch, I would lose access to the switch, and I plug it in to port 2. Let's see. I would obviously need to take off my static IP address from my device. Okay. So let's see what it comes back with. Network, we have some network access. So I got an IP of 192.168.20.11, which is the first IP of my DHCP range. So what I need to do now is get my command prompt to open. Right. So let me open my command prompt. Okay, so now that I have my command prompt up, I'm going to plug into port 2, which is in our user VLAN, so we should get an IP address of 20 dot something. That's an old IP. Please, let's renew. And we got 20.30. So I was testing before and I got 11 and 12, which is where my scope started. So I should be able to ping my gateway 192.168.20.1. That is our first sign of connectivity. That means that we can reach our switch because the gateway does exist on the switch, not on. Yeah, it's not actually configured on our device. We get the gateway and everything from the DHCP configuration. So what I'm going to do is, make sure I can still ping our gateway, and I am going to access the device using the gateway IP. Root. So our second test would be to test connectivity in the other direction. This would also be via ping, so I'll be pinging 192.168.20.13. That's expected because my firewall is on. I think I brought this up in one of my previous videos. The firewall has to be off with pings to wake. So once I turn this off, our pings should come back up immediately. And this is what we want. So I am going to test on another port. Just give me a second. Okay, so I'm leaving these pings to run. I'm going to unplug this. My potty session will stop because my connection to 20.1 will no longer be active. So I'm going to close this session and we are going to reopen it shortly with our new IP. So I'm also going to close this off. So the next port I'm going to plug into is port 4. Port 4 right now is configured for our guest wireless VLAN, which is VLAN 50. So our IP address should be 50.13. Let's plug in. Let's see what we have. So I still held on to the IP, so let me release and renew. This is the release and renew is just to force it to change IP addresses faster. So it would change an IP if I leave it, but I want it to get done faster, so I'll do a release and renew. So again, I should be able to ping my gateway of 50.1. Good, and we should be able to access the device using 50.168.50.1. Same thing, root, because I already turned off my firewall, my ping should work fine. So ping 192.168.50.13 and our pings are working. So that proves our network connectivity. We wouldn't test into VLAN routing. I mean, we tested that in our last session. So in our next session, what we are going to do is look at the Juniper SRX firewall. We are going to start our firewall configurations to allow users to access things like the internet. So I hope you all stay tuned for that, and I hope you all are enjoying the series so far.